community. So without further ado, I will hand it over to Aaron to wow us.
All right. Thank you. Thank you very much for the kind intro, Stephen. And also shout out to Gabe, our streamer, for always putting out the dope streams and setting everything up. All right, let's get into everything. So I'm gonna share my screen here. And we are going to talk about extracting, loading, and transforming data really efficiently with Laravel today. I know that's a beast of a title. I would have loved to just say ETL, but I wanted to make it explicitly clear what the process is. If I really was smart, I would have said extracting, transforming, and loading to stick with ETL, but here we are. So I hope everyone can see my screen and hear me. If you can't, anyone on the Google Meet, just chime in, but I think we're good. So what does ETL even mean? We're going to get into all that, and I'm really excited about this because we've got a pretty sick demo to go through the whole process of building an ETL pipeline. Again, we're going to go over what all that means throughout this talk. But we got a demo where we have one process that's going to be inefficient and not inclusive of an entire ETL process. And we're going to step by step improve it to make it totally inclusive of a full ETL process and make it way more efficient throughout the whole demo here. So I'm really excited. I think you're going to learn a lot here. And a big takeaway that I'll review at the very end here is that what you learn here is not just going to apply to building ETL processes, because you might not do that every day, but chances are you're building web applications or mobile applications or getting data from some source like a database. A lot of these principles you're going to learn today can directly apply to all of that. So I think you're going to learn a lot of fun stuff today. Before we get into that, the talk is by me. I'm Aaron Krauss. I am a senior software engineer at Clevyr. Before we get to that, though, I'm the code boss on a lot of social medias. I don't use social media as much these days, but I've been getting more into Reddit again. I was pretty into that a handful of years ago. I work at Clevyr. I'm a senior software engineer there, and I build web applications, mobile applications, software applications, a lot of behind-the-scenes stuff, front-end dev whenever they let me. It's I've been in this game for a little over a decade now, and it's fun, and I just like to solve problems. I think is what it comes down to. At Clevyr, we're a software consulting company. We're based out of Oklahoma City, but we have been hiring a lot of developers out of Tulsa, and that's we've worked with people across the nation before too. We actually even worked with a guy from Canada for a while. So while we do specialize in working with local clients a lot, we also work with companies nationally. One of our biggest clients is a top 10 company in the world or the United States, one or the other, I forget, but big company that is not based out of Oklahoma. So we like to build people what they want, I think is what we do. So getting back to the talk, this talk is going to include a little bit of slides and a lot of live demo. I think I set that stage a little bit ago. So a big note I want to make is we're going to do a demo with Laravel. However, this is not a talk over Laravel. I'm not going to be preaching this is how Laravel does things. I'm just using Laravel as a tool. We use Laravel a lot at Clevyr, especially over the last couple of years, and we love the tool. I love it a lot. I'm historically a Rails developer from a while back, and Laravel is like the Rails of PHP. And I like Laravel a lot. I honestly don't like PHP that much. I'm sorry for everybody else, but I love Laravel. Laravel is awesome. You don't need to know it, though. We're going to review everything that you would need to know in Laravel in this talk, and I think everything will make sense. So getting back to ETL. So what does ETL mean? Well, you know the acronym from the title, extract, transform, load. What does that actually mean? And are you doing ETL? Well, I'm going to bet you're probably doing it more often than you think you are, because at its core, it's a really simple process. And this is the image. It's from the meetup page as well. But the whole point of an ETL process is to take or extract data from some data source or multiple data sources, as you can see here, transform it, and load it into a data store or multiple data stores that you then have access to do whatever you want to do. The extract and load is pretty simple. Taking data from some third-party source, or it could be your own source, it doesn't matter, but some other source of data. Load is pretty easy too. You're loading it in there. This transformation layer is where a lot of that magic happens, and we're going to focus on a lot of that process today. The whole idea behind this transformation layer is Let's take an example of like the Apple iOS news app. There's a ton of different publications that it pulls from, like Washington Post, CNN, etc. And each of those data sources are going to store data a little bit differently. So what this app, I'm pretty sure behind the scenes is doing, can't verify this, but I'm sure behind the scenes it's extracting data from all these various APIs, transforming it into one standardized form of data that the iOS app is going to use, and then load it into a database that the iOS app is going to use. So while, let's say the Washington Post, an article has, let's say if I'm looking at that API and there's a field called body that represents the article, but let's say that CNN has a data field called just data that also represents the article, this transformation layer will handle that and set it all into one single unified way structure of data that will then load it into this process. And that's just a very simplistic view of an ETL process. One of the bigger benefits of transforming is pre-processing data to make it where if there's any heavy computations that you would want to run on data, you would ideally use those, build those in your transformation layer here so that when your app needs those computations, it just loads it like that because it's already done. You've already pre-processed that data. We're going to get into a lot of this. If this isn't 100% clicking yet, that is A-okay. Like I said, a lot of live demo. So you've probably heard the phrase ETL pipelines before. That just refers to this right here. It's a workflow of data. This is just a pipeline. With any sort of data, doesn't matter if it's ETL or whatever you're doing, you can only do two things with it. You can read data or you can write data. Well, reading data is pretty simple. You can read it. There's not really any other ways to read data besides just to get the data. With writing data, there's a few operations that I'm sure you all are familiar with, but they are different, and I want to call them out. You can insert data, you can update data, or you can delete data. You all may have heard of the CRUD acronym for create, read, update, delete. It maps to if you were building a CRUD API, for example, or a CRUD application for handling data. 3 of those are write. 1 is a read type thing. So I just want to spell that out. And this is an example of how that applies to an ETL pipeline. You have an old data source, which is where you can extract data from, a new data source, which is where you're going to load data into. And this is different. This is how you might think about inserting, updating, and deleting data between between your extract layer and your load layer. If your extract layer has data that your load data doesn't, you're going to insert it. If your load layer has data that your extract layer doesn't, you're going to delete it because the whole point of an ETL process is usually to keep in sync with other data sources. And if there's overlap, then you're going to update that data, because what if going back to the iOS app example, what if CNN had a typo in one of their articles and we've already synced it over, but they fixed the typo? We still want to capture that. So that's this update process here. We're going to go over this. We're going to show this graph again, or this Venn diagram again later when it makes a little bit more sense. But this is just a preliminary example of how you would think about writing data with an ETL process. So I told you a little bit of slides, a lot of live demo. We're going to bounce back and forth between slides and demo to go over some more concepts. But let's get into things. We're going to get into a quick intro into Laravel. After that, we're going to talk about the data. Actually, we're going to talk about the data now, but you'll start seeing the data after we do an intro into Laravel. And what our demo is going to be is we're going to take data from like a retail store that has multiple items and just convert it into another retail store that has items. So taking it from taking an old store, if you will, and all of its items, transforming that data, putting it into a new store, trying to keep it as simple as possible. And this is what that's going to look like. We will have 2 database tables that represent our data that we're going to be extracting. And we're going to be taking that data, transforming this, that's what these dotted lines here represent, transforming it, and then loading it into 2 other database tables that are just going to be called store and item. This is very simple. The goal of this is not to build some astronomical ETL process that is an actual business use case. We want to just review concepts today, and this will help us do that. So with an ETL process, a lot of the times you will be not using the same database. You'll be using databases from other sources. In this case, this is all in the same database, but that doesn't change any of the process. Everything else is having different databases just means having different links, different URLs to pull from. But the concept-wise, we'll be able to accomplish everything we need to with just this pretty simple example. So let's talk a little bit about our ETL demo. I'm going to hop to my command line here. So I'm going to be using the command line predominantly for everything. We use Vim to show the code. And then step by step, we're going to run some commands here that actually run our ETL process. And it runs in a matter of seconds so that we're not, we don't have just have a bunch of empty space in this talk, but it's enough time where you'll be able to see what is efficient, what's not efficient. So going into the code, let's talk a little bit about how Laravel is set up. If you've used Laravel before, this is going to look familiar. This is our standard directory structure. There's a couple directories that we've added for standardization at Clevyr, like I believe this Docker directory. But in general, this is a pretty standard setup. I'm not going to go over everything, but in general, our code, typically backend code for Laravel, will live in this app directory, which will have a bunch of subdirectories. We'll spend most of our time in this area. Database is the other big one we'll talk a little about. It handles everything database-wise. You can probably gather from these folders what we're doing. We have a factory. We have a series of factories. We have migrations. We have seeders. That's where we'll start in a second. Some of these others probably look familiar. Node modules. Public is any of our public files that are just not bound behind any sort of authentication. Resources are our assets. JavaScript, CSS, images, fonts, all that. We're not going to mess with any of that today. Routes are API routes, not messing with that. And then some of these, I'm not going to dig into the rest of these, but this is a standard Laravel setup. And what we're going to do here is let's start looking at the actual database seeder. So you can see how the data we have set up is right now. So this is a standard seeder in Laravel. And right now it's just 2 lines. That's it. We are saying we're going to create 1,000 old stores from a factory. We'll dig into that in a sec. And we're going to create 3,000 old items. So our database for preparation purposes is going to have 4,000 records. 1,000 of those are old stores. 1,000 of those are old items. These are set up as models. If you're familiar with an MVC architecture, model view controller, this is the model layer. We're creating these, and that will actually create them in the database. And to show that, Postico open. Our database is a Postgres database, and Postico is a Postgres database management tool. So we've got some tables here. A lot of these are Laravel specific tables that we're not going to mess with. We're only going to mess with 4 of them, actually. Items, old stores, and stores. So old stores will have 1,000 records, and they're all randomized right now. I'll show you how that happened. But you can see some of the data tables. We've got some of the columns, name 1, name 2, some address information, some pretty generic stuff. And we've got some items. I'm sorry, that's our new items. This one is empty and should be empty. I meant to look at old items. We have 3,000 records here. Name 1, name 2, a quantity field, a foreign key back to our old store, and timestamps, of course. Primary key. Pretty simple structure so far. Looking back at the code here, I want to make sure that there's a fundamental understanding of the data before we mess with it. So we've got factories here. Those are housed in this factories directory, which if I go to old store factory, it's a pretty simple file. It's about 33 lines, I think, if we just keep going down. And the big thing is that we get to prep the properties that we want for a standard old item. And we're using a tool called Faker. Laravel ships with that to set random data up. You can kind of assume what the data represents here: company suffix, street address. And we're just setting the keys to our fields in the database table. So that's our old store factory. Same thing with old item. Very simple. We have name 1, name 2. Our quantity is set between 0 and 20. That's just a different type of data. And then old store ID represents the foreign key back to our old store. Because we only had 1,000 old stores, I'm just randomizing the number between 1 and 1,000. You can do this in a more elegant way in Laravel. You can actually reference it to like an old store object, but this was just the easiest thing for me right now. So that's how we got this set up, for example. Quantity is between 1 and 20. Old store ID is between 1 and 1,000. Okay. So that's our data setup right here. Let's talk about our actual code. So we'll spend the rest of our time in this app directory. So I mentioned we're going to write a command line operation that will run our ETL process. And that's a pretty standard way to run an ETL process, whether it's Laravel or any other tool. It's a behind the scenes thing. There's usually never a UI with an ETL process. You might have a UI if you were going to have some sort of merging of data, but a lot of them are going to be behind the scenes. So we're building this as a console tool. That's why we're going to put this in the console directory, Laravel, and we're going to hop into commands. Laravel ships with a really nice way for us to be able to run a command line this way. This is the command I'm going to be running, although we'll be incrementing the steps. The code is already written. We'll just be going through the steps. PHP artisan and then command name. Oops. PHP artisan command name. There we go, get that ready. Is how we actually run it. The DC exec app is just I'm running this tool in Docker, and DC is an alias for Docker Compose. So that's just how we're going to implement. That's how we run a command on a container that's running in Docker Compose. We're not going to talk about Docker in this talk, although I'm sure we'll probably have a Docker talk. Actually, we had one in January, so yeah, we'll check that out if you're interested in learning more about how containerization works. So this is what we're going to run. Digging into the code, finally, you see we have 9 steps here. That's the amount of commands we're going to run. Each one builds on each other, so they're not separate steps. We take the exact code from the previous step and just modify it, and we get from, like I said, an incomplete and inefficient process, complete it and make it efficient from steps 1 through 9. So let's get started talking about our ETL process. So a standard Laravel command, I'll show you from the top just so it's not confusing. We've got our class here. Step 1, that's just the name of the command. We have a variable here, an instance variable, step 1, that refers to how we actually run the command. So step 1 there refers to how I say step 1 here. We have a description that I'm not using at all. Again, it's for demo purposes. You would, of course, want to fill this in. But this is if I ran a -- help after the command, then it would print out this command description. We have a constructor here that does nothing except call the inherited constructor. And lastly, we have our actual code of what we're going to run. This handle function is a standard for Laravel commands. I didn't write that. It ships with that. All I wrote was the code inside the handle function. So what we're going to do, first of all, getting into our ETL process, our goal is to take data that's in old store and old items and convert it or load it into item and store, or store and item. Again, both stores, old store and store, has many items. Now, in between there, we want to transform that data. That's the whole process of it. That's the whole portion, the whole goal of an ETL process is to transform that data. And we'll talk about what that all means. But let's get a simple example going here. For starters, this is just a helper line for me for demo purposes. Between each of these steps, I want to clear out the database of the new stuff, not the stuff that we're importing from. And this just clears out the table. It cascades to the items table as well. So it'll clear out the new store and new items table. So this will count as a database query, but this is not an actual portion of the ETL process. It's just a helper thing for me. Anything after start here will actually be the ETL process, and it's pretty simple for starters right now. Laravel's ORM of choice is called Eloquent, so any sort of query like this where we're using a model and then getting a database query like this, that's using Eloquent. We are going to be using the Eloquent ORM throughout this, and honestly, it's very helpful. And we'll dig into the intricacies of how queries work with an ORM like Eloquent. So for starters, we're going to run a database query here to get all of the old stores, which is going to be 1,000 records. So not too crazy. We're going to iterate through each of those stores, and then we're going to run a transform function on them. This is something that I wrote, and this is completely developer opinionated. This may not be how you do your transformation layer, but I'm going to go and show you what this does. And we're going to get back data that has been transformed and is ready to be loaded into our new store table. So that's what we're doing here. We're going to create a store record. Notice how this is the store and not an old store record. And we're going to create it based off of the data we get back from this transform function. So nothing too crazy right now. And we're only handling insertions right now. We're not doing anything for deletes or updates. That's why this is incomplete so far. So let's look at the transform function for an old store, and that's going to be in the model directory down here. We've got all of our models here. So let's look at old store. And if you've never seen a Laravel model before, this is literally just about it. We have really the only important thing that we've got a function here that represents items that has many relationship to items, and it points to old item. And otherwise, the only thing we have in here is our transform function, which all it's going to do is return an associative array of key value pairs that will correspond to what a new item would expect. So to show that, we have a full name field, a full address, a full name key, a full address field, and an old store ID key. If we look back at Postigo, let's go to our store table, full name, full address, old store ID, and everything else is timestamps and primary key. So we don't need anything else. So these columns map directly to this. I want to talk about the old store ID. With any ETL process, you need a way to link the data you're loading into the data that it originated from. So you might ask why that is, but let's go back to that iOS app example where I mentioned if CNN had a typo in their article, we need a way to know what the article that we created on the app is, what it refers to, the original article that it refers to, so that we can update it, basically. So that we can say, if we need to update it, what does it point to, so that we know how to update? And then also, if you remember that Venn diagram, we need some way to know, have we imported this data? Have we not? Do we need to insert it? Do we need to delete it? So we just need some reference to the data that it came from. So that's what this old store ID is. Okay, let's go back to our step 1 command. And again, very simple process. We load all the old store data, iterate through it, transform it to get an associative array of new data, and then we create a store out of it. Easy peasy. Let's run that. It will run relatively quickly. We'll see that start command. So that start should indicate whenever our ETL process runs, because that'll run after the table gets truncated. And that ran in a matter of seconds. If we go back to Postigo, we can look at the data. Bam, we have 1,000 records, full address is concatenated, full name is concatenated, old store ID is, we assume, a valid ID. We're good. Things we're missing, we haven't imported any items yet, so we need to do that. That's going to be our next step. But that was a relatively painless process. So I mentioned this is inefficient. Why is it inefficient? Well, we're going to get into all that, and some of you might have been able to tell already. But before we do that, let's go on to step 2. We took the exact same code, and we're just modifying it a little bit more. It's just this exact same code from step 1. Nothing changed here. However, now we're going to start thinking about items. So a store has many items. So what we want to do here is we want to iterate through each store that we're in now, iterate through each of those store's items. And then we want to do the same process. We're going to transform the old item to get our new item, and then we're just going to create that item. Now, there is one little difference here with this process. We do have to pass in a variable to the old item's transform function. This is because when we're creating our item, the new item, we need a reference to the store that we created with it, so the parent store. Well, if we go to old item, let's go to that model. Old item, and here actually, this might even be easier if I go back to the data. Whoops, I jumped way ahead in slides. So if we go back to this, so we're creating this item, well, but we need a reference to this. Well, old item doesn't have that, and it never will. So we just have to pass that in manually. So that's why if we go back here, if we look at our transform function, we pass in the store ID. What we're doing is it's very similar to our old store process. We have our key here, our amounts, our old item ID. These are just properties that exist on a new item. However, if we do pass in a store ID, then we're also going to set the store ID foreign key. This is just a simple way to do it where if we don't pass it in, we won't set it. If we do, then it gets set. And we return that. So same idea of a transform function as we had with our store. So we pass on the store ID, which we nicely have because we're already in that store's iteration. So we know exactly what store we need to pass in for that item. And again, this is pretty simple to understand. Conceptually, we don't have a ton of code here. We're creating data. Let's take a look at how long this takes to run. And after we hit start there, this one's going to take a little bit longer. And you might expect that because we're talking about more data. It'll take about 11-ish seconds to run. And that's kind of where you start getting into the thoughts of, is this the most efficient process? And actually, we don't know how long it took to run because we don't have any sort of metrics. We're not tracking any of that at this point. We just know it took a chunk of time. So let's look back at this. Well, what can we do to improve this? Well, there's quite a few things we can do to improve this process. But before we do any of that, we need to know how inefficient we are. So the next step is all about adding metrics in. So we need to know how long that this process has run so far, just using a simple timer. And we're going to also track the database queries that were going on, because that's the main third-party integration at this point, where you're just communicating to and from the database. If we were communicating to a third-party API, we would want to know how long those are taking, how often we're querying those. We're not doing any of that here. So just simple database queries are going to be what we're going to use to see how efficient we are. Well, for starters, we added a tool called Stopwatch. It just starts a timer. It's very simple. We start a timer at the beginning of our process here. We have it at the end here. Let's just see, and otherwise no code was changed, 0. So let's see how long that runs. Again, same code as step 2. And like I said, it should come in at about 11 seconds or so. And we're creating 4,000 records. And that's not a trivial amount of data. Look, this one actually ran at 12.5 seconds. So 12,500 milliseconds. The 4,000 records, we can make that better. That's not a ton of data. But it's also not no data. So why would it take 12,000 milliseconds? So the next metric tool that we have added already is a behind-the-scenes tool that ships. That it's a free package that you can get with Laravel. Any other tool will have that, and it's called Telescope. And it's a separate PHP package we had to install, but it's free, and it just runs with our app. But this allows us to get insight into anything that we're doing with our app. So you can see some of the things that we might check over on the side here. We use this at Clevyr a lot, and I have made some radical improvements with this for help. We're going to stick to this commands tool right here so we can see how long we can dig into our particular commands. So we saw step 3 run here 49 seconds ago. That's the one. So that will take a second to fetch the data there. And once we get it back, we get some log information here. And the big thing we want to look at are these queries here. So this short process that we've had so far runs 5,002 queries. And now we're getting into the core of what's going on. How can we improve this? Why are we running 5,002 queries with literally this amount of code? It's 14 lines of code. This is where if you are, I think a lot of people aren't as big a fan of ORMs because they feel like it hides what you are doing. I don't think that's a good argument to make. Because I think the whole concept of an ORM is incredibly valuable as far as just simple code, simple version controlling of your database operations in your code. But if you weren't thinking about what was going on here, like if we weren't thinking that we had 2 nested loops here and we're doing database queries in those, and this may not look like a database query, but it is. That's where the inefficiencies can stem from. So we have 5,002 database queries with this pretty simple process. And you might think, how on earth is that happening? But let's just take a look. Let's see if we can map them out. Well, for starters, one of them is going to be the store truncate queries. That's a misnomer. That has nothing to do with anything. So really, we have 5,001 queries we're trying to map to. But so we'll just ignore this one, but that does account for a query. We have one query here to load all stores, all the old stores. That's one query, nothing big there. We're going to iterate through them. We're going to transform the data. There's no database queries here. We're going to create a store. This is a database query. And because we're in a loop here, this is 1,000 times that this is going to run. So we have 1,000 database queries here that's running. Continuing on, we're going to iterate through each of those stores items. And this is actually one where you might not expect it. This is running a database query right here, because let's get into a core idea of how ORMs work. By default, many of them lazy load data. It really depends on what tool you're using. But what that means is that up here, we only queried old store data. We didn't query anything else. And by default, Laravel, unless I explicitly tell it to, Laravel and Eloquent are not going to query anything more until I need it. And for example, right here, I didn't need items until right here. So whenever I run this, Laravel will query all of the items for this store. And because we're also in that loop for each store, this is 1,000 queries again. So we're up to 2,001 queries. I guess 2002 for including that truncate at the top. So 2002 queries. We're still 3,000 queries behind. What accounts for those? Well, continuing on, transforming old item data. There's no database queries here. Here's the last 3,000. We are inside of a loop, and there's a nested loop here. And there's a total of 3,000 items of old items. So we create a new item 3,000 times. And that's 3,000 queries right here. So that's why this takes this long, 12.5 seconds, which maybe that even sounds impressive to you to be able to run 5,002 queries in that amount of time. But we can make this better. And this is where we're going to start from, making things better. So for starters, what we need to do, before we dig any deeper, actually, talking about building a good ETL process, the first thing you need to do is you want to pre-process the data as much as possible. This is not necessarily for the efficiency of your ETL process. It's for making your application as efficient as possible. So this won't actually speed anything up on your ETL process. But the whole idea here is we have a transformation layer for like old items and old stores, for example. You want this to be as valuable as possible. Ideally, you're not just duplicating or copying data over. Ideally, there's some way that you can run aggregations, combine fields like we're doing here. You can do something where in the tool the application you're building that will use the new database, the new data, you want to cater to that. And there's no right, I can't tell you how to do that. It depends on your application's needs. But pre-processing data is the whole, a big point of an ETL process. So that's going to be step zero, step one, for sure. Next thing, and yeah, I think this just iterates what I was just mentioning. You want the data to end up in the way that'll make the rest of your application the most efficient. Next thing we want to do is track metrics. Well, we just did that. The next thing we want to do after that is we want to implement bulk queries. If we go back to Telescope here, we see we've got the 5,002 queries, and it'll tell us 5,002 queries, 4,997 of them of which are duplicated. That doesn't mean that the exact query is duplicated because the data can be different, but the type of query is duplicated. And that means that insert into items, that you see a ton of those here. You also see some insert into stores as well. But we can batch these up. If you're familiar with SQL, you're bound to be familiar with the bulk insert. That's where we're going to start with this process. So let's start taking a look at step 4. Before we start, let me start at step 3 just so you can see where we were. Before we make this completely efficient, let's take this bit by bit. For starters, one thing that we can do really easily is we can write just literally less than a line of code. And I'm going to go to the bottom here. So we're in step 4. I'm going to bounce back and forth between step 3 and step 4 to see if you can tell the difference that we just did. So there's step 3. There's step 4. One more time, step 3. I feel like I'm an optician here, doing A, B. But we're in step 4. You might have seen some change up here on this line. And that's all we changed. So I mentioned Laravel and Eloquent by default lazy load data. That means it won't query data until you need it, which is why we are dealing with this as its own separate query on this line right here. We never needed items until this line, so we query it now. Well, Laravel and Eloquent give you the options to change that, and you can eager load by default. And what this query will do instead is it will load up all the old stores like we were doing before, but it will load up all of the items with those stores. And the way it gets items is because we have that in our model here for old store. We have a function called items. So it will use that. And it has many relationships. So Laravel knows what to do there. So that's all we're doing. We're saying get the stores and their items. It'll go ahead and map up those stores with the items. So the first store, if it has 2 items, it'll go ahead and map that up to the data right here. So instead of one query to get all the old stores, what we're doing here is Laravel will run 2 queries behind the scenes, one to get the stores, one to get all of those stores items, and then it will automatically merge all the data together. So this was now going to be an array of stores with their items. So that means when we get down to here, even though we didn't have to change the code at all, this no longer runs a query for each store. So we save 1,000 queries here while only spending 1 extra query. So we save 999 queries. So if we go back to our example here, not step 9, we're not there yet. If we go to step 4, we will save a little bit of time here, and then we'll check out Telescope, verify that we saved our queries, and go from there. So that ran in 10,000 milliseconds, almost 11. So we saved a little bit of time there, not a ton, but we're getting into the ideas of how do we batch our queries up. And if we go back to Telescope, let's go back to our commands here. Let's look at step 4. Let that load. So we have 4,003 queries. Like I said, we saved 999. We're on our way. We're getting there. We can make this better, though. So now we get on to where we have to start rethinking data. We did as much as we could using simple fixes with this, eager loading. But honestly, we need to get rid of this double nested loop. This is just killing us right here. So taking that to the next step, we need to keep the logic as flat as possible. And this is where you're kind of deviating from the idea of using data, how it's related, into thinking how can we do things in batch actions, because usually batch actions don't work well with related data. So we're going to go to step 5, and this is going to be our first deviation in the process. So we still started with our same code, and I'll show you from the top there. But this process is going to be a little bit different, because instead of inserting 1,000 stores and 3,000 items separately, we want to batch those up. So the way we do that is a little bit conceptually different. And this is where the power comes in of knowing how to organize an ETL pipeline. So let's start here from the top. We still get our old stores with items. That didn't change. This is where we have a change. Instead of looping through and creating each store individually, we're going to iterate through each store using a map function, which if you're unfamiliar with how a map function works, it allows you to apply a function on every item of an enumerable, like an array here. So we're going to just run the transform function. That's exactly what we did before. And we're going to convert it to an array. In Laravel and Eloquent, they deal with the data structure called a collection, which is just a fancy array or a fancy object. But whenever we bulk insert into our store model like this, notice we swapped out create with insert. This will actually run a bulk insert for SQL. It accepts only an associative array, not a collection. So we got rid of our for each. We still have an iteration, but this is fine. We're not doing any sub operations in there. So this will run one query to bulk insert all of the transformed old stores. We're keeping this flat. We're not looping through the stores anymore. So we got rid of 999 queries here and swapped it out with 1. I'm sorry, we got rid of 1,000 queries and swapped it out with 1. So again, we saved 999 queries. Next line here, we're going to come back to this because this is where you get into how do you start thinking about this whole data restructuring. Let's talk about this next line here. Well, we're doing the same thing here. We're iterating through all the old stores, getting all of their items instead of transforming them. So now we have an array of arrays after this because we had an array of old stores and each of those had a subarray of items. Well, we're just going to flatten that here. So we have just a single level array of items. So this will be, after this line, we'll have 3,000 items as a single array. You might wonder why I query the data like this, as opposed to just using the old item model. It'll make more sense in future steps, because I agree this probably is a little bit more complex than what it needed to be right here. We're going to map through these, and the end goal is also getting back our transformed old items. Now, here's where we get to a little bit of complexity. Flat logic doesn't work very well with related logic. So before, when we were nesting our items underneath our stores, we knew what store we were in for those items, so we could just pass in the store ID. Well, we don't know that anymore. We have a flat list of items that we don't have a direct reference to the store. So what we have to do is we have to start thinking about how do we have key value mapping pairs of data that we can access that then gets us to where the data that we actually need. So thinking about this, an item has a reference to, an old item, that's what we have here. An old item has a reference to an old store. So what if we created a key value pair of old store ID to new store ID? Because once we insert this data, we will have that here. So that's all this is. It's a key value pair, an associative array, where the key is old store ID right here, and the value is ID. So old store ID to new store ID. That's it. This is just a simple way in Eloquent to get just those fields and make them an associative array. So that's what we're doing here. We're using this to, in memory, determine what is the actual parent store of the new item that we should be creating. There's no queries going on here. We just ran one query here to get this data, but we just use this in-memory tool, this associative array, to get that data. This is where you have to start thinking in your head a little bit different than what might intuitively make sense right off the bat. But this is how we keep our logic flat. So same thing, we have our array of new items. We insert them into our items table, and that's it. I say that's it. I know that was a lot, but conceptually, we're doing the same thing. We're just flattening it all down. So taking this next step here, Step 5, this runs in, bam, look at that. We went from 12,500 milliseconds to 1,600 milliseconds. That's a crazy improvement. And if we go back to our command here, let's take a look and see how many queries. So we have 6 queries now. And again, one of those is a misnomer. That's the truncate. That has nothing to do with our process. So realistically, we went from 5,001 queries to 5 queries. That's just crazy. And this is much more scalable because before, a lot of those 5,000 queries were based off of the data that we were importing. We're not doing that anymore. We're doing bulk inserts that aren't explicitly tied to the data that we're importing. Now, we're not done by any means, but I think this is probably the biggest brain jump you have to get over to start thinking about how to make an ETL process efficient. Let's keep going because we got our step 9 here. The next steps, honestly, take these concepts that you just learned and start applying them to deletions and updates, because this is as efficient as we're going to make the insert process. We've done our job here. So before we get into here, let's go into our, actually, I don't think we're ready for our next topic yet. I think it's, oh no, we are. This is that Venn diagram again. So how do we know what we need to insert, update, and delete? Well, previously we were just wiping out the database and inserting everything. That works, but of course that's not a realistic view of how you can run an ETL process forever. You need to handle updates and deletions. So we talked about this Venn diagram and how we know what we need to update and how we know what we need to delete. That's what we're going to start doing with this next step. We're going to start preparing. How do we know what to update? How do we know what to delete? And what we're going to do to detect this Venn diagram, we're going to use the primary keys of the old store, so that we know what data does exist in our old store table. We're going to get a reference of the old store from our new store data, so that we know how much data has actually been created out of the old data. And this represents our 2 Venn diagrams here. So just a list of keys represents extracted data that we need to extract and data that's already been loaded. And all we do here, honestly, this probably looks like a bunch of mumbo jumbo, but we're just trying to determine what records do we need to add, what records do we need to remove, what records do we need to update. And we're just doing Venn diagram type stuff. We're seeing what's the difference between the old IDs and the new IDs. And that's going to represent this portion of the Venn diagram. So that's just a list. Same thing with the delete. We just swap them and see what's the difference between them from the different angle, like what's the difference between this circle versus this one, and that leaves us with all the data that we need to delete. And then everything in the middle here is what we need to update. So we just have a list of IDs that we need to update, delete, and insert. And all we did here, so we have a list of IDs. All we're doing still is inserting data, but instead of inserting all data, we're just passing in the IDs that we need to insert. And we extracted this to an insert stores function. If we hop here, exact same logic, except for one if statement at the very top. Everything we reviewed is right here, nothing new. The only thing I added is if there's no data, we just return. Because if the list is 0, then we're not going to do anything. So this will take a little bit more time because we have some operations here, but no extra database queries, just some actual in-memory processing. And then this will get us set up to delete and update the data. So you can see we put some info, some logs here. That's what this is right here. So we can see how much data are we inserting, how much are we deleting and updating. So going on to our next step, step 7, we add delete stores. This is very simple. There's actually this is already as efficient as it's going to be. If we go to delete stores here, we just pass in the IDs we want to delete. And all we do, this is the whole function here. Nothing crazy. Nothing we need to make more efficient. Same if statement here. If there's no IDs, we're not going to do anything. And we're just going to delete the data. So store, where in old store ID, delete it. Like I mentioned at the very beginning, stores and items are related in the database. And we've got a cascade set up where this will also delete all of those stores items. So we don't have to handle item deleting. We only need to care about the stores here. So delete function is done. Honestly, that's all this step is. We'll run it. It's going to just, so in this case, I actually removed the truncate. So if we go back to the bottom, there's no truncation here. So this looks like it runs super fast. That's a misnomer. We actually just aren't inserting any data, and we haven't written the update process yet. But if there were any records to delete, we would have deleted them, and that would have been a very quick operation, single query. Last thing we need to do is talk about the update process. So And if we go to the very bottom, we have a function called update stores. We pass in the IDs. So let's look at what this function does. In a nutshell, this does the same type of behavior where we get our stores, but we're starting from our inefficient process here. We're getting all of our stores, a single query here, iterating through those stores, finding the actual new store that maps to it. So that's the query here. We're going to update the store with the transform data, and then we're also going to iterate through the items of that store and update those. So you can see we've got that nested loop here. You can probably just smell the inefficiency already, and I will not delay you any longer because there is some inefficiency here. So if we take a look, we'll let that run. It will take about 9 seconds. If we go back to our commands here, step 8, that took 4,004 queries. So we're back. We were super efficient, and now we're back to square one. So updates are actually a little bit unique because you can't, as far as I'm concerned, do a bulk update in SQL. If that's wrong, feel free to call me out in the chat. But each update has its own unique properties that need updated because you don't know what's going to be updated. So we will have to still iterate through each thing to be updated. But where the process can be improved is if there's no update that needs to be made, then we don't need to make a database query. Or before that, we can bulk update the queries. So let's get to our last item here. Well, let's talk about the queries here first. We have one query here. We're querying once for each store. That's 1,000 queries. We're updating here. This probably looks like a query, but actually Eloquent is smart enough under the hood to know if we don't need to update a record, then it's not going to actually run the query. So because we had already loaded the store, it won't run this update query because I guarantee you nothing has changed in the last 10 minutes that we've run this. However, when we get through right here to load the items, and we're still eager loading, so this is not a database query. However, this will run an update statement because we never preloaded the item like we did the store here. We never evaluated the where statement and then ran an update. We're just running an update. So this actually will run 3,000 update queries when in fact no data has actually changed, and that's inefficient. Well, just like what we did with the insert process, we can improve that. And I'm not going to dig through this in depthly because we've already gone through a lot of the concepts here, but we're getting into the thought of you only want to write data as needed, and that's one of the final optimizations that we're going to talk about. You don't want to writing data takes more time, but they're more expensive than reads for a handful of reasons. You're writing to a file behind the scenes, wherever your database or data store is storing it, even if it's in memory, or it's getting stored somewhere like a physical, like a physical medium. And you're breaking database cache. Databases can be very optimized if you need to read the same data over and over again, but if you're constantly writing data, then you're breaking that cache, and that's going to cause long-term inefficiencies in your project. So you want to minimize writes if you don't actually need them. And in this case, because we're not updating actual data, any update we were doing was just updating with the same data. That's still it's still an inefficient process. Well, right here, we're doing very similar type stuff, and this is how we're getting our list of stores that are mapped from the old store ID to the new store ID. However, we also need to do that for items now because we need to know both sides. We need to know what store did the new store relate to and what item did the new item relate to, what old item did it relate to. And I mentioned that we still have to keep a loop, but we don't have to keep a nested loop here. So we still need to iterate through this list of old stores, which we queried up here. So that's one query there. But we'll actually get what we're doing here. I should probably run through these queries. We're querying all the old stores here, and we're querying all of the new stores here, but we're grouping them by this ID here. And this is simulating our key value approach for being able to say, okay, what's the right store for this old store ID? And that's an in-memory way for us to get access to the data here. So we need the actual store data to know if we need to even update it. This is a list of stores we get back, but it's grouped by the old store ID, which is what we have access to when we're extracting data from the old store. So we're getting a copy of the store, the new store here. This is not a database query because we're just filtering a list. We're not even filtering, we're just getting the key of an associative array. So up here, this is this makes up 4 database queries, 1 for each line. No database queries here, and no database queries here, because as long as there's no updates, if a store needs to be updated, then of course there will be a query here. But because we know there's no updates here, this query will not run. Eloquent is smart enough to know that there has been no change. And same thing with the items here. There's been no change here. Same process. So we save a significant amount of queries here. So let's just see how fast this final piece of the puzzle that officially handles inserts, deletes, and updates runs. So it runs in 2,300 milliseconds. We can try it again just to see. And we're always going to be updating because we're no longer truncating the table. So yeah, we're getting very efficient here. So that's at least 4 times as efficient as what we started with. And our final thing to really add here for efficiency purposes is we want to implement database indexing. And this really depends on how your application works. In this case, there's not enough data to really get value from database indexing, but I've still added I've still added some database indexing that's not in there yet. I'm going to migrate a last migration that will index a few fields, and I can show you what those fields are. If I go to our migrations, I'm just going to hop to create indexes here. This is the migration that adds some indexes. We just basically index every foreign key because this is how we commonly query data. Indexes will only benefit read queries, and they will actually make your write queries take a little bit longer, minimally in this case. That's because we have to add the index for each item we're adding. But it's trivial. The amount of time you save the amount of time you can save is astronomical. So in this case, we're not saving a ton of time, but if I run this again, we should save about like 100 milliseconds or so, maybe 50 to 100. So, and that's about right. We saved about 50 to 100 there. If we run this again, about 50 to 100 milliseconds. Again, it's not enough data to really get a true value out of it, but in large amounts of data, you can, and a lot of complex queries, you can get so much value out of database indexing. And we still are here. That's still what, 3 to 5% efficiency with literally running one thing that's now set in stone. It'll always be 3 to 5% more efficient. So that's awesome. So that concludes the demo portion of our talk, and we're on the way out here. So, and we're done. We've got our efficient ETL process where we have got inserts, updates, and deletes taken care of. We are efficient as can be. If we had any records to insert, it would get handled. If we had any to delete or update, those get handled now. Now, there's a disclaimer I need to add. One big problem with this is this is not a perfect ETL tool, despite what you might see with the times. There's a couple problems, one of which is we're not paginating through table data. We're making queries to get all of it. That works okay with the amount of data we have right now, but it will not work for hundreds of thousands of rows or beyond, even thousands of rows you will want to paginate data through. And I didn't include that because it really doesn't change the mindset you have to go through for handling ETL processes. You just have to iterate through data. So I didn't want to have to worry about explaining that and going through that in a pretty short talk. So, but we're not doing that, and you would need to account for that. And then ideally, you could use a modify that field to limit reads. Right now, we're querying again all of the data. Well, if you know in your old database that it hasn't been modified in like a week or a day or something, then you don't need to do anything with it, right? But in this case, we just aren't accounting for that. And I left it out as well because some of the ETL processes that I've done have modified at dates, but they're not reliable. So we just had to ignore them as if they weren't even there. So some takeaways are just reviewing these 5 items that we went through: pre-process your data, track metrics, implement bulk queries, keep your logic flat, write only as needed, and implement database indexing. There's a big takeaway, though, is that none of this only applies to ETL processes. And this is where we're rounding home here. Just a couple things that I want to share. You can use these concepts in all of your data-driven projects. So how do we take these concepts of ETL to the next level? So for starters, you can offer and build multi-granularity syncs. What that means is that right now we're syncing all the data. But like I mentioned before, if your new data wasn't being modified, then you don't need to sync all the data. Or maybe you only want to sync active data and then maybe overnight sync all the data. It's up to you. It really depends on your process. And we're going to get into some of the layers that we've built at Clevyr. And actually at one of our projects that we're going to talk about, we built 3 granularities of sinks: quick sinks, full sinks, and overnight sinks. We're going to dig into what that means and right now. So an example is we have a Pharmaceuticals Client that we were syncing data from an old database of theirs, and an old database and a new database. There was actually multiple layers that we were extracting from. First of all, database indexing, we took the loading of the initial dashboard page from 7 seconds to 1 second. That's pretty radical. That doesn't mean the page didn't load until 7 seconds. It just means that all of the data on the page didn't load. We had some spinners that were loading data from API requests. But database indexing, that's all we did. That improved things astronomically there. But on the ETL side, we had a lot of data that we were syncing. So we built a quick sync that synced all of the active data that we were aware of. We had a full sync that synced any active data that was in the legacy database that we may not have caught yet, but it was only active. We weren't accounting for inactive data. And then we had an overnight sync that synced all data, and we're talking millions of rows here. And that took 2 hours. So it's a quick sync we ran about every 10 minutes, I think. Full syncs run every couple hours. Overnight syncs run overnight. You get to decide how you want to run these. But this is not only is it a viable option, but you should think about this when you're building an ETL process, because you likely don't need to sync. All data is not always the most important. You probably have a small section of really important data that impedes your workflow, and then you have all of your data. So you just kind of got to think about it. And last example is we have an oil and gas client where we had an ETL process, but this is actually not involving their ETL process. This is just good web application practices with a combination of pre-processing data, implementing bulk queries, and keeping logic flat. We took a site load from 18 seconds to 1 second. That's astronomical. And again, same thing. It didn't prevent the 18 seconds didn't mean that the site didn't load for 18 seconds. It just meant that all data on the site didn't load until that time. And we took that experience way down. The client was incredibly happy. So how do we do that? Well, we actually didn't use database indexing for this. We removed 500 queries from the dashboard that no one knew were happening every single page load. And we did that with all the tools you learned about today, Telescope, and just figuring out, okay, what's calling these queries. And we removed a lot of processing of the data on the client side because at that point in time, we had already pre-processed a lot of data on the server. So that was a new process we had added, which kind of sparked us wanting to redo how we handled dashboard data. But through a combination of all those tools, we made this experience so much better. And the last thing I'll just end with is that as far as an ETL process goes, I mentioned that extract and load are pretty easy to understand. The transformation layer is where you can really make some big gains for your application. So just when you get to that point of pre-processing your data, I want to encourage you to really think about it and think, how can I make improvements that help my current application and the future of my application? So that's it. I know we went a couple minutes over, but I appreciate everyone sticking around. So I'm the code boss. I have the codeboss.dev for my personal portfolio and blog site. And otherwise, I will open it up. Actually, here's my company I work for, Clevyr and Clevyr.com. I've been with Clevyr for over 5 years now, and I love it. And I work with Gabe, our streamer there as well as a bunch of other people. We are looking for a project manager right now, actually. So if you are interested in that role, hit me up. And if you're a developer, just, again, hit me up, because we're always looking for developers as well. That said, I will open this up for any questions.